Okay, welcome to SAT Prep. We're going to do the SAT Practice Test 1 from the College Board website. I have a link written right at the top here, which is also posted down in the description below. So if you want to work on this independently and then come back and we'll walk through these together, or we can just walk through it together, right? So again, that link will be down in the description below. In addition, there is an ACT series that I've done, which is also going to be posted down in the description. So if you're taking the SAT, sometimes it's good to look at the ACT questions because they're pretty similar to each other. So you can use that as some additional practice if that's something you need. Okay. So just to kind of give you a little background, the SAT test is in 2 sections. Okay, we're going to be doing the first one in this video, which is the no calculator section, which is 25 minutes in length. It is 20 questions, okay, and the last 5 of those 20 questions are open-ended, right? So the first 15 are multiple choice, the last 5 are open-ended, which they use grid bubbling in order to kind of collect your answer, okay? So, but there won't be any multiple choice for those ones. You'll just have to give your answer. So when we get to those ones, we'll talk about that, but let's get started, okay? First problem, okay? I'm sorry, not first problem. Let's talk about the instructions real quick. So no calculator permitted. There is going to be a reference sheet available to you, which I'll show you in a second, okay? And I think the main important thing here, you can read through these yourself, but this third one that says figures provided are drawn to scale unless otherwise indicated. So what that means is for any geometry problems that we come across, if something looks like a right angle or looks like an obtuse angle, it probably is, right? If you take a look at 2 lines and one is significantly longer than the other, then when you do your calculations or your work, your answer should match that idea, that the longer line should have the bigger number and the smaller line should have the smaller number, right? So that's what they mean by that, okay? Otherwise, I think they're fairly straightforward. If you have any questions about any of these instructions, you can post that in the comments below, okay? Here is your reference sheet. Okay, so these are entirely geometric formulas, right? So you can see that we have circles, rectangles, triangles, both for area and for the Pythagorean theorem. We have 30, 60, 90, and 45, 45, 90 special right triangles, and these are all then volume problems for prisms, cylinders, spheres, cones, and pyramids, right? So all volume, okay? And then down bottom, just some important facts about degrees in an arc, radians, and the sum of the measures of a triangle is 180, okay? So if you take a look at this, if I were to summarize it, it looks like we have primarily area, okay, volume, and then we have a little bit of trigonometry, right? These 3 right here are all triangle related, and then they give you the circumference of a circle. So the reason to kind of ingest this now and talk about it now is because as you come across these problems, you'll know, oh, okay, that was one of the facts that I was given on the reference sheet. I should go back and get that formula, right? If you're familiar with what's on the reference sheet, you know what to go back and look for if you come across it in one of the problems, okay? All right, so let's get started. Let's go through this review, okay? So the first one says, x minus 1 over 3 is equal to k, and k is equal to 3. What is the value of x, okay? So for all of these problems, what I'm going to do is show you the kind of math way to do it, and then if there are any tricks to either check your work or to, if you're stuck on how to do it, how to maybe get to the answer anyway, we'll talk about those. But instead of just showing you tips and tricks, I want to actually show you the math so that you can kind of go through it that way. Okay. So for this problem, if they tell me k is equal to 3, I'm going to come over to this equation that I have to solve, and I'm going to plug in a 3. So it's going to say x minus 1 over 3 is equal to k, which is 3. Okay. And then to solve this problem, I'm going to multiply both sides by 3. This says divided by 3. I'm going to multiply to get rid of it. Okay. Got to do that on both sides. Right, so my dividing and my multiplying will cancel, and it's going to leave me as x minus 1 is equal to 9, right? 3 times 3. I'm going to add that 1 to the other side, and I'm going to get a 10, okay? So that is my answer. In this case, D is equal, choice D, which is 10, okay? If you weren't sure about this one, you could just plug in these numbers, right? Whenever they talk about what is the value or find the solution, and they're giving you a list of values, what that means is when you plug in that number, it should work, right? So if you notice, if I plug in 10 minus 1, right, that makes 9, over 3, that is equal to 3, and that is what k is, right? So if you're not sure how to do these algebra steps, you can plug in the values and see which one does give you a k value, which is 3, okay? All right, problem number 2. For I is equal to the square root of -1, what is the sum of 7 plus 3i plus 8 negative 8 plus 9i, right? So this part right here is an Algebra 2 topic. This is called complex numbers, right, with I. But for this particular problem, that's not really necessary because when we're dealing with I, a lot of the regular old algebra rules apply. So in this case, we're just going to combine like terms. 7 plus negative 8, these are like terms. So I'm saying 7 plus sign negative 8. Well, that's negative 1, okay? And then I'm doing 3 plus 9, and that's a positive 12, right? So in this case, we're going to say choice letter A, which is negative 1 plus 12i, okay? Problem number 3. Hey, it says Armand sent M text messages for each hour for 5 hours. Tyrone sent P text messages each hour for 4 hours. Which of the following represents the number of messages sent by them on Saturday afternoon? Okay, so here's what I like to do with these type of word problems where you're trying to write an expression. I like to give myself a specific example, right? So for example, if I was talking about Armand sending M text messages, well, let me just replace that and say Armand is sending 3 text messages each hour for 5 hours, right? So let's just think about that. If he's sending 3 text messages each hour for 5 hours, he's going to end up sending 3 and then another 3, and then another 3, and then another 3, and 3. Looks like he's going to send 3 plus 3 plus 3 plus 3, right? He's going to send this many. If he sends for 5 hours, that looks like 15 messages, right? So 3 plus 3 plus 3 plus 3 is 15, right? So it looks like an easier way to get that would just have been to do 3 times 5, right? So I can say if I take the number of hours times the fact that he sent 3 text messages, that's a good way to figure out how many Armand sent, right? I can do the same thing with Tyrone. If Tyrone is sending P messages every 4 hours, and I'm going to say that he's sending 2 messages every 4 hours, well, he's going to send 2 plus 2 plus 2 plus 2, right, which is 8. And in the same way, 4 times 2, right, those numbers, I can just multiply those together. So I could do this instead as 4 hours times the fact that he's sending 2 messages an hour, right? And then if I add these numbers together, it says which represents the total number of messages sent by both of them. Well, it looks like in my specific example that I'm using, the answer would be 15 plus 8, which is 23, right? So if I take this specific example and I generalize it back to instead of being 3, I do M, right? Here's what I'm going to get, right? I'm going to get rid of the 3, which I used as my specific example, and I'm going to get rid of this 2, and I'm going to replace them with the variables. So in this case, M, okay, and P, okay? And so it looks like what I need to do is 5 times M plus 4 times P, and that's choice C, okay? So again, I like using specific examples just to figure out what I'm doing, right, if it's not entirely clear to you just by, having seen it before, okay? All right, problem number 4. Okay, Kathy's a repair technician, right? The number of phones that she has to fix at the end of each day can be modeled by this equation where P stands for the number of phones left and D is the number of days she has worked in that week. What is the meaning of 108? Okay, so here's what I like to do for this one. Again, specific examples are good ways to kind of see what's going on, right? If I take a look at this problem and say 0 days have passed, right? If I plug in a 0 for D, I'm kind of saying like she just started the week, no days have passed, what's going on, right? It looks like it's going to be 108 minus 0, which is 108, right? Okay. And P represents the number of phones left, right? So on 0 days, right, before she started, it looks like she has 108 phones to fix, right? And then if I say, okay, what happens when it's 1? P equals 108 minus 23 times 1, right? Well, that's going to be just 108 minus 23, and that looks like 85 that she'll have left to do, okay? So you can see that it looks like it decreased by 1, she'll have 85 left. But it looks like what we're saying is that this 108, that's kind of our starting point, is how many she had at the beginning of the week, right? And then as the days go on and she's like repairing phones, that number is going to decrease, right? So we're going to say that it's the starting value, okay, of how many phones she has to fix at the beginning of the week, right? And I like this first example as a good way to say at 0 days she had 108 phones. Well, that's the start of the week, right? So that's what that's representing, okay? Problem number 5, okay? This looks messy, okay? But all this problem really is a subtraction problem, so it's combined like terms. And here's what I recommend, okay? If I talk about x squared y, which is this first term, okay? Whenever there's a minus sign in between two expressions, I like to distribute that to the other ones. Otherwise, you're going to have to do minus negatives, and I feel like that's the spot where most of these errors occur, right? So if I subtract these, okay, it's instead going to be x squared y minus 3y squared plus 5xy squared, right? That's the first expression, right? The second one is going to become, let me just move this over a little bit so I got some space, okay? The second one is going to become, instead of being minus, I'm going to be able to write plus, okay? And I'm going to be able to distribute this minus sign to all three of these, so they are going to change signs. So it's going to be positive x squared y, okay, negative 3xy squared, okay, and positive 3y squared, okay? So now what I'm going to do is I'm going to look for like terms, right? I see an x squared y and another x squared y. I'm going to add them together, and I'm going to get 2x squared y, okay? And then I got negative 3y squared plus positive 3y squared. Well, that cancels, right? Negative and a positive cancel each other out. And then it looks like the last one is 5 plus negative 3, and that's going to be 2xy squared, right? So this choice C in the middle, right, that would be your correct answer. Problem number 6, moving right along. Okay, a pediatrician uses the model above to estimate the height h, right, so h represents the height of a boy in terms of the boy's age a in years between the ages of 2 and 5. Based on the model, what is the estimated increase each year? So let's take a look at this equation, okay? Again, I like to use specific examples. If I say 3a plus 28.6, right, and that's going to be equal to h, if I decide to plug in, this is between the ages of 2 and 5, right, I'm going to say, okay, the first one is going to be 3 times 2 plus 28.6. Well, that's 6 plus 28.6. That's 34.6, right? So it looks like at the age of 2, he's 34.6, right? If I try then to do the same thing and say, well, what happens instead of plugging in a 2, I go to the next year, because that's what they want to know about the boy's height each year, right? If I say 3 times 3 plus 28.6, okay? Here's what I want you to remind you about. This is not a calculator section, so they're not relying on you doing a lot of calculations. So let's just think about this instead of doing the calculation, okay? When I go from 3 times 2 to 3 times 3, all I'm doing is essentially adding 3 more, right? That's what that increase is doing. It's saying instead of having 2 3s, I'm going to have 3 3s, right? So I'm going to add 3 more to this, right? So it looks like my number is going up from 34.6 just to 37.6, right? So it looks like that was an increase of 3, and saying what is the estimated increase of the boy's height? Well, it looks like it's 3, right? Every single time we increase the number of the age another year, right, from 2 years to 3 years to 4 years to 5 years, this number is just going to increase by 3 every single time. So that's why we're going to say that the boy's height will increase 3 years, okay? Okay, look at this disaster, okay? So the formula above gives monthly payments, okay? Which of the following represents P in terms of M, R, and N, okay? So here's what I want to point out about this question. When it says gives P in terms of, what they're basically saying is I want this to be P equals something, right? So currently this is an M equals, right? So if I were to reword this in kind of plain English, what they're really saying is instead of this being solved for M, I want you to solve it for P, okay? So what that means is this thing, this whole like mess of an expression here just needs to be moved to the other side, okay? So let's kind of take a step back. This is really messy, but all it really is fraction over a fraction times a number, right? So instead of it being M equals all of this stuff, I'm just going to do a fraction. Like let me do like, I don't know, 3/2 P, right? So this is just like, again, a mess of stuff, but it really is just a fraction. So let me see what I would do here. If I wanted to solve this for P, what I'm going to do is I'm going to multiply by its reciprocal, okay? And on this side, I would multiply by its reciprocal, right? This would cancel. Now it's solved for P, and it looks like what happens is I just get the flipped over version. Instead of 3 over 2, solved for P, on the other side, it's 2 over 3, right? So that's really what I'm going to look for is I'm going to say, okay, let's make sure I have P equals, and I'm going to look at this and say, okay, R minus 1200 needs to be on the bottom, right? Okay, so choice A is out, right? I see R minus 1200 here, right? This one's got the N, right? So this one looks like it's good. 1 plus R over 1200 minus 1. That looks flipped over. Let me just check the other ones. No, those are much simpler versions, right? So I'm going to say choice B. That's all you got to do, okay? So again, sometimes with these complicated ones, they can be overwhelming. Just give yourself a simpler example of the situation. It's fraction times p. Well, this one's fraction times p. The same rules should apply, okay? All right, next problem. Number 8. If a over b is equal to 2, what is the value of 4b over a? Okay, so if I say a over b, and I'm going to change this a little bit. Instead of writing 2, I'm going to write 2 over 1. Here's why, okay? There's a rule that says if I flip over the left and make it b over a, I'm doing that because that's what they want. They want b on top, a on bottom. I'm going to flip over the other side as well. So instead of being 2 over 1, it's going to be 1 over 2, okay? So now I have b over a is equal to 1 over 2. In order to make it say 4b, that means I'm going to multiply the top of this one by 4, which means I need to multiply the top of this one by 4. Right? So now it's 4b over 2a. I'm sorry, 4b over a is equal to 4 over 2. Well, 4 over 2 is just 2. Right? So that would be my answer. All right, number 9. Okay. What is the solution x comma y of the system? Okay, so here's what I want to remind you about systems. Right? A system of equations is just two equations where we're going to combine them in some way so that we can figure out what x and y are as a shared solution, right? So lots of ways to do this. My favorite way is the elimination method. I think it kind of works a lot better while avoiding fractions. The test itself, if you look at a lot of the explanation of problems, they actually use the substitution method. They'll both work, but I'm going to show you the elimination one, okay? So the first thing I'm going to do with this problem is I'm noticing things are not lined up nicely, right? This one's got the y kind of first, and the one above it's got the y second. So I'm just going to switch these. It's positive 2y, okay? I'm still going to leave the negative 19 alone. And then this is a negative x, so I'm going to put that here, okay? So the reason I'm doing that is because now I can look at this and see how easy it is to eliminate the y's, right? If I just multiply this bottom expression, right, the whole thing by negative 2, right, here's what I'm going to end up with. I'll still have 3x plus 4y is equal to negative 23. I'm not changing the first one at all. But the second one I'm going to say negative 2 times negative x. Well, that's just positive 2x. Negative 2 times positive 2 is negative 4y. And negative 2 times negative 19. Don't forget that the other side needs to be multiplied as well. Right, so that's going to become a positive 38. Okay, so here's what I'm left with. Now if I add down these columns, 3x plus 2x is 5x. 4 and negative 4 eliminates. That's what I wanted to happen. I specifically made a 4 and a negative 4 because they cancel each other out. And then it looks like here I get, if I add these together, I get a 15. Okay, so x is equal to, if I divide both sides by 5, it is equal to 3. Okay. Now, if this was like a regular algebra class, you would have to go back and plug in, but I don't nearly need to because if I know x is 3, this is the only answer that has that. Okay, so I can kind of just say that's my answer. And here's what I want to point out about this. If you get to the test and you're like, I forget how to do this, how to do the elimination method, how to do the substitution method, or maybe it's just not working out and you're not finding these answers, remember whenever you see this word, solution, what that means is if you plug in the solution to the problems, it should work. Here's the catch, though. For systems, it has to work in both, which means you need to check it in both, right? So if I check my answer here, if I plug in an x value of 3, right, and a y value of negative 8, so this says 2 and negative 8, okay, that says negative 16 minus 3, yep, there's negative 19. That works, right? If I also check it in the one above it, this says 3, my x is 3, so that's going to go there, and then my y value is it's 4 times negative 8, right? So that looks like negative 32 plus 9, and that does make negative 23, right? So if I forget how to do this stuff, I can go through and check my answers, but just remember, you only have 25 minutes, so that's a backup plan, right? I'd rather just be able to do the work, okay? All right, problem number 10. For the function g defined above, that's this thing, okay? A is a constant, and g of 4 is equal to 8. What is the value of g of negative 4? Okay, so here's how we're going to do the problem like this. Okay, if they say that g of 4 is 8, that means that the 4 is an x value, right? And the 8 is kind of a y value, right? But it's also kind of like we'll call it, instead of y, call it the output value, right? So this g of x, this whole thing, can be replaced with 8. So I'm going to plug in these two numbers, and I'm going to say that 8 is equal to, right, a, and then I know that my input value is 4, so this is going to be 4 squared plus 24. Okay, so here's why I'm doing this. If I square this, it's 4 squared, 16a plus 24, okay, equals 8. Okay, And then if I subtract this to the other side, 8 minus 24 is negative 16. Okay? And that means that A is negative 1, right? So if I rewrite this now, if I know A is negative 1, I can say g of x is equal to negative 1x squared plus 24. And then that lets me plug in this expression to find out what is g of negative 4, right? Because I eliminated this other variable by finding A, now I can just plug in to find out what g of negative 4 is. So this g of negative 4 just means plug in an x of negative 4. Negative 1 times negative 4 squared plus 24, okay? And so if you notice, negative 4 squared is 16 times negative 1, okay? 16 times negative 1 is negative 16 plus 24, okay? The answer is 8, okay? That's my answer, okay? All right, problem 11. Okay, in the equations above, B and C represent the price per pound of beef and chicken, where B is beef and C is chicken. X represents the number of weeks after July 1st during the summer, during last summer. Okay, what is the price per pound of beef when it was equal to the price per pound of chicken? Okay, all right. So here's what we can think about for this one. A couple of different ways we can do this. One way is to just say I want to know when beef and chicken's prices were the same. So I could do this just as an algebra problem and say 2.35 plus 0.25x should be equal to 1.75 plus 0.4x, okay? And I can solve this. And if you're comfortable with this type of work, this is a good strategy, okay? So let's do that first, okay? So if I subtract 1.75 from 2.35, right, you end up getting 0.60, okay? And then if I subtract this 0.25 back, we get equals 0.15x, okay? So this is my expression. And then I'm going to divide both sides by 0.15, divide by 0.15, okay? And you're going to end up getting, oh no, I don't have a calculator. How am I going to figure this out? Well, here's how I figure it out. If I want to make this bottom not a decimal, I can move the decimal point 2 to the right, 1, 2, okay, and make it a 15, okay? And that just means I have to move the top 2 to the right, 1, 2, right? There's a 0 here, so this one's going to become 60, okay? So 0.6 over 0.15 is the same as 60 over 15. So well, 60 over 15 is just 4, okay? So I find out that x is equal to 4. That's not one of the choices here. They said, what is the price per pound of beef when it is equal to the price per pound of chicken? Right? Well, when I find x, all I'm calculating is the number of weeks, not the price. So what I need to do is take this now and go back to one of these equations and plug it in for x, and that will tell me what the price was, okay? If I'm staring at these two problems, okay, I'm actually looking at the first one and saying, this one looks really good for plugging in a 4, right? 0.25 is 1/4 times 4, and that just makes 1, right? So if I plug in a 0.25 times 4, I'm going to get a 1 plus, okay, 2.35, okay? And if you notice, one of our choices is 3.35, okay? So that's the correct answer, okay? Again, if you're not comfortable with decimals and a lot of the stuff that was just done here without a calculator, here's something else you can do, okay? If I look at what this equation is saying, it's saying as every day increases, this one's going to go up by a quarter, this one's going to go up by 40 cents. So I can also make a table, right? I could say, okay, on day 0, the first one's 2.35, right? And then, well, let's call this B and C, right? So let me grab my eraser so this looks nice, okay? So the beef value is going to start off as 2.35, and the chicken value is going to start off as 1.75, right? This is on day 0. So let's make another column over here for x, right? So when x is 0, I get 2.35 and 1.75. When I increase this to day 1, the beef is going to go up 0.25, so it's going to go to 2.60, right? And then if the chicken is going to go up by 40 cents, so that's going to go up to $2.15, right? So I can see they're not equal to each other. So then I can say, okay, well, on day 2, it looks like this one's going to go up another quarter, so this is going to go up to 2.85, right? And then the next one is going to go up 40 cents, so this one's going to go to 2.55, right? Looks like we're getting closer to each other. And I'm just going to keep doing this, and we already know that we have to get to day 4, but you can see what I'm doing is I'm just kind of taking what they told me, which is quarter increases here, right, this looks like it's going to go up to $3.10. All right, and it looks like the 40-cent increase is going to make this $2.90. Right, and then the last day, right, if I increase this by a quarter again, it would be 3.35. If I increase this one, oh, I'm sorry, this is 2.95. Right, if I increase this one by 40 cents, I'm also at 3.35, right? And there's where they're the same, okay? So if you didn't know how to do the algebra, you can also just kind of chart out what's going to happen, right? And you can see that we get to a reasonable answer. So that's an alternate strategy for this type of problem, right? And hopefully that will help you if you're stuck on the decimals, okay? All right, problem number 12. In an xy plane, okay, we are going to pass through the origin and have a line that has a slope of 1/7. Which of these points is on that line? So here's kind of what's going on with this. We have the origin, and then we have a slope of 1/7. So here's what I want to remind you about. I'm going to write something that you might have, might sound familiar to, right? Change in y over change in x, which is sometimes referred to as rise over run, right? So that's what slope is, right? So what that means is we're going to change the y, in our case using the 1, and we're going to change the x using the 7. So that means I'm going to go up 1, okay, and over 7, right? And I'm going to end up at the point 1, 7, okay? That means that that point is on this line, okay? Up 1 over 7, okay? There it is, okay? I'm going to do the same thing, and if I go up 1 again, okay? Oh, I'm sorry, that's backwards. This is not the correct answer, okay? I have to be careful. This is the point 7, 1. I knew something was wrong, okay? 7, 1, okay? 7, 1 is not a choice here, okay? But if I do it again, if I go up 1 and over 7, okay, I'm going to increase the y value by 1, I'm going to increase the x value by 7, and I'm going to up at the point 14, 2, and there's your answer, right? That's the correct one. So be careful. Y is on top. Y represents the second value, right? So we have to make sure that when we increase 1, we're increasing the second value. I almost made that mistake, so just be very careful, okay? All right, problem number 13. Again, messy looking problem. This one is definitely more algebra heavy, okay? So here's how we're going to handle a problem like this. I'm going to pull the expression. They're basically saying this is ugly. Which one of these is the same but nicer, like simplified? So I'm going to say the expression looks like this. 1 over x plus 2 plus 1 over x plus 3. And our job is to simplify this in some way. So here's the first thing I'm going to do. I'm going to forget about the top of this just for a second, and I'm going to say I would really like to put these together, okay? Here's how I'm going to put these together, okay? If I multiply this whole thing by x plus 2, x plus 3, okay, I'm going to get essentially a common denominator, right? So here's what's going to end up happening, okay? Let's do that, okay? If I multiply this first one by x plus 2, x plus 3, the top is going to look like x plus 2, x plus 3 over x plus 2, okay? And this whole thing's being multiplied by it, okay? And so then the second part, this one's also going to be x plus 2, x plus 3. Okay? And on the bottom of this second term, I have an x plus 3. Okay? And if you notice what happens here, we get some nice canceling happening. So what I end up with is x plus 3 plus x plus 2. Well, that looks like 2x plus 5. Okay? So that's the kind of bottom there. Okay? And so I actually, what I did was multiply this whole bottom by x plus 2, x plus 3. Okay? And so because I multiplied the bottom by that, I also need to multiply the top by that. Okay? Okay? So that means x plus 2, x plus 3 is going to show up, because if I'm just doing times 1, I'm going to get that. If you notice, x plus 2, x plus 3 is really, if I FOIL that out, x squared plus 5x plus 6. And on the bottom, I'll have a 2x plus 5. That's going to be this answer right here. Okay. So I'm multiplying, basically, it's going to summarize this problem. I'm multiplying the denominator by both of these terms to cancel them out. But because I multiplied the bottom by both of these terms, I have to multiply the top as well. Okay, so that's how I got that answer. All right. Problem number 14. 3x minus y is equal to 12. What is the value of 8x minus 2y? I'm sorry, 8x over 2y. Okay? So here's what we're going to do for this one. We're going to say, I'm going to start with this thing, right? And I'm going to say 8x over 2y, or 2 to the y. Okay? 8 to the x over 2 to the y. Okay? 8 to the x over 2 to the y. There we go. Okay. So what I'm going to do for this problem is I'm going to say, well, 8 and 2, I can rewrite 8 as base 2, right? We always, with exponents, want to try to get the bases to be the same if we can. So I'm going to say 8 is the same as 2 to the 3rd power, and then I had that x already up there. They're just going to be multiplied together. The bottom is 2 to the y. Okay? And we had this rule, and I'm going to remind you just with kind of what you saw when you learned this rule. Right? If I have a base that is the same and I have a fraction bar or a division sign between them, I can subtract these and I can rewrite this as x to the 6 minus 4, right? Or x squared, right? That's kind of the rule that you've seen. So for this problem, I can do the same thing. They both have base 2. I can rewrite these with a base of 2, and instead of writing separate problems, I can subtract them. So I can write this as 3x minus y, okay? So I was able to rewrite this expression. Okay, let me get rid of this stuff so it's not distracting. Okay, I rewrote this expression as 2 to the 3x minus y. Well, if you notice, that's exactly what they have here. 3x minus y is the same thing as 12. So that means I can replace a 3x minus y with a 12. Okay, 2 to the 12th power. There it is. Okay, that's our answer. All right, problem number 15. This is the last one in the multiple choice section. Okay, this one's a doozy, so strap in. Okay, so they're saying ax plus 2 times bx plus 7 is equal to this thing where they have a c missing in the middle. Okay, and they're telling us that a plus b is equal to 8. Okay, so here's the first thing I'm going to do. The right-hand side of this expression is kind of it's called standard form, right? No parentheses. The left-hand side's not. So I'm actually going to like FOIL this one out, right? So I can see, kind of compare them side by side, okay? And it's going to be pretty messy, but we'll fix that in a second, okay? So if I multiply together ax times bx, okay, I'm going to get a, b, and then x times x makes x squared. Ax times 7 is just 7ax, okay? 2bx, when I multiply those inner terms together, okay? And then I get 2 times 7, which is 14, okay? So if you notice, okay, I have kind of this thing, and then I'm going to write below it what it equals, which is this, right? So I have 15x squared, okay? I have plus cx plus 14, okay? So I can kind of draw some conclusions from this. The first one is that a times b should be 15, okay? And if I add together these expressions, I'm going to get what c is, right? So they're saying, what are the possible values for c? Well, it's really this thing, right? I know that a plus b has to be equal to 8, right? Okay. And I know that a times b has to be equal to 15. So let's think about this. What multiplies to 15? Well, it looks like 3 times 5. Again, let me erase so it looks nice. 3 times 5 makes 15. Okay. And the only other option is 15 times 1 equals 15. Okay. And I need ones that multiply to 8. Right? A plus b is equal to 8. Well, 15 times 1, 15 plus 1 does not equal 8. 3 plus 5 does equal to 8. Okay. So this is the pair that I care about. So here's kind of the catch. When it's saying what are the possible values for c, right? And how does this play into it? Here's the idea. I know I have to use a and b as 3 and 5 because those are the only ones that add to 8. Okay? But I don't know if a is 3 and b is 5, or if it's the other way around. Maybe a is 5 and b is 3. Right? That's why there are two possible values for c, because I have to kind of include both possibilities. So here's how I'm going to wrap this one up. I'm going to say, let's take our 7ax plus 2bx, which represents the c, okay? And let's plug in, I'm going to start off by plugging in a is 3 and b is 5. So if I do that, here's what I get. 7 times 3x plus 2 times 5x. Okay? Well, that's 21x plus 10x. Well, that looks 31x. Okay? So one possibility is that the c value, right, because it's cx, is 31. If you notice, there it is, okay? And just to show you, right, if I do the same thing and flip them, instead of a being 3, I make a the 5, I can also say 7 times 5x plus 2 times 3x, okay? Well, that looks like 35x plus 6x. Well, that's 41. There's your other answer, okay? So if you want to confirm, there is your last choice, okay? So I'm going to stop here, and we're going to do the last 5 problems, which are all open-ended questions, as a second video. So stay tuned for those. They will be coming in shortly.